Hi there, so this is my video for this year's Festive Tech Calendar. We are going to look at how to build a naughty elf detector. More on that to follow, but the technologies we're going to use today include creating an image classification model using custom vision AI, then implementing that in a Xamarin iOS application, using the real-time feed from the iPhone camera to detect a naughty elf in the frame of the camera and then react accordingly. Oh, first I've got to show you my Christmas jumper. It's almost Festive Tech Calendar law that I have to show you my awesome Christmas jumper. It's got Baby Grogu, a Mandalorian themed Christmas jumper. The best Christmas jumper you have ever seen. I'm sure you'll agree. Right, okay, so what do I mean by naughty elf? So I of course mean Elf on the Shelf. Every year in December, the elf on the shelf plagues families, usually with children. So children wake up every morning and these naughty elves have gone and done something a bit naughty in the night, and they're usually quite funny, and usually there's a mess for the parents to clean up. So I thought I would see if I can create a naughty elf detector and trap them. No, not really trap them, although that would be amazing. Right, who am I first of all? So I am Lee Engelson. I am the developer relations lead over at Avanade. Avanade are probably the largest IT consultancy you've ever heard of. There's 60,000 of us across many countries all over the world. We have 73 Microsoft MVPs, of which I'm one of them in developer technologies. And I'm also on GitHub, LinkedIn, Twitter, and YouTube. So please do follow me, help me get my follow numbers up, and hopefully Twitter will still be around this time next year. Okay, so before we talk about this year's talk, I just want to talk about last year's talk. I'm saying talk a lot. The last year for Festive Tech Calendar, I did something similar, but I did analyzing static images, and I created an image classification model that would discern whether a tree was a regular tree or a Christmas tree. Did that tree have decorations and lights, or was it a regular tree? And it could detect trees that were an unusual shape but decorated and said, yep, that's a Christmas tree, or it could detect fair trees which might look like a Christmas tree, but because they're not decorated, I wasn't counting them as Christmas trees, and that was quite successful. You can look at ischristmastree.com. It's all on the web and on my GitHub, so you can look at the code for that and see how I've done that. But this time we're going to be looking at analyzing real-time camera feeds. And these are the steps we're going to take. We're going to train the image classification model, then we're going to test the image classification model, and then we are going to implement it in a Xamarin iOS app, and then we're going to play around with that just to make sure it works and have some fun, because why not? It's the festive holidays. Okay, so first of all, we are going to train the model. So I need to jump out over to Custom Vision AI for this. So, yep, that all looks good. Let's just drag that across. So as you can see, I've got my project all ready to go, but if I was creating this from scratch, I'd go ahead and click New Project, give it a name, and description's optional. The resource just needs to be a Visual Studio subscription. Then for the project type, I'm choosing classification. I couldn't get object detection working with the sample that I found and extended, but we'll stick with classification. It does the job. Then, because we're only going to tag each image with yes, there's an elf, or no, there's no elf, then we want single tag per image, so it's multi-class. Then this domain, I chose general compact S1 because it just works, and it also says, oh, if you're going to export to iOS and Android, this is quite a compact domain, so you might want to use this one. And I've kept the export capabilities as the default there. So let's close on out of there and go to one I created earlier. So for this one, you need to upload your images, and you just click add images, upload as many as you want. And here's my training data, which is all sorts of images of naughty elves doing various naughty things, and then upload them. And you also need to select a tag, or sorry, choose a tag, and I chose elf. And then in order to reduce the likelihood of false positives, you need to upload a bunch of images that don't have the elf in. And I've included some images of maybe soft toys, some other toys, some various office scenarios, and some general backgrounds. And none of these contain the naughty elf. And this is my way of just saying, if you come across any of these, the elf's not in here. Okay, so it's using both the images containing the elf and images that don't contain the elf to train that model for us. So once I have uploaded all my images and tagged them as saying elf or no elf, I then want to go ahead and train that model. So if I hit train, it's going to give me two options, either quick training or advanced training. I always choose quick training. I've never needed advanced training. I couldn't even tell you what it does. So yeah, quick training, that will take about 5 minutes. So you can go away and make a cup of tea or something. Generally what I do, well, coffee to be honest. And then once you've trained that model, you will want to test it. And once you've trained it, it will come back with a score, and it will say how well it managed to create this model, and using some of that information, what confidence it has in its ability to that the model's a good one. And I've done this a few times. You can see I'm on to iteration 5, and usually because those numbers were a lot lower, so I've added more images. In particular, I added more images without elves in, and then ran it a few times. So I'm up to iteration 5, and I'm quite happy with the scores and the performance I'm getting. So once it's created the model, you want to test it. So we're going to click quick test, and then I'm going to go to my test images. Now it's really important that you don't include these test images in your training model, because we want the model to be able to detect if an elf is in there or not. And it'd be a bit unfair if we gave it actual images, the exact images that we wanted it to find. So none of these images are in the training model. So let's give it some of these images. Here we go. We've got a elf brushing its teeth, making a mess, of course, saying it's 99.9% sure there's an elf in there. Let's try another one. Let's try this one. A couple of elves playing the floor is lava. We of course have got 2 elves now. They seem to be multiplying. 99.9% sure those are elves as well. So let's try and trick it a bit. Let's have a bit of a messy room. It's saying it's 99.3% sure there's no elf in there, which is good. And then let's pass it some action figures, various Marvel action figures. Here it's saying that's 98.9% sure there's no elf in there. Okay, so there we go. That is, we've tested a few images, so happy with that. The next thing we want to do is export that model. Now I've created it. So if we hit export here, it's going to give us a bunch of options depending on what platform you want to use this model on. Because we're going to be using it on iOS, we want Core ML. That's iOS's machine learning format, I guess. So yeah, we go ahead and take that, click that, export that, download that. We're going to need that in a minute. Then jump back to the talk. Yeah. Okay. Bear with me. Right. Okay. So we have used Custom Vision AI. We've actually tested the model as well, and we're happy with it. I've jumped ahead of myself a few slides here. Next, we need to implement the model. I am not going to go a really deep dive into the code. Instead, I'm going to save you that. Instead, what I'm going to say is go to this GitHub URL. The Xamarin iOS samples, and go ahead and get the iOS 11 Core ML as your model one. And what this does is, if you open up Visual Studio for Mac and then deploy this to your iPhone device, it will detect fruit. So what I've done, and what you can do too, is just replace any reference to fruit ML model C in that code locally with your model, and update any references in the code to use your model. Run it, and it will be able to detect naughty elves. Again, sorry for not going too deep. I wanted to keep this quite high level and light, but I've done all this. I know it's possible. So just replace the fruit model with your naughty elf model. And the only other customization I've done to this code is maybe change the color of the indicator. So if it detects elf, I'm saying red. If you don't detect elf, go green. And if you detect the elf, play a bit like a siren alert sound as well. I'll also mention that you can tweak various things in here. So for example, I'm pretty sure it's not analyzing every frame in that camera feed. I think it's analyzing every third frame. So you can tweak that for different performance reasons. I don't really think this, you need the frequency of being able to detect the ELF in every single frame. So yeah, the fewer frames you analyzing, the easier it's going to be on the application. Okay. So once you've done that, deploy that to your phone and let's see what the results are, shall we? So from left to right, I've got the naughty elf on my bookshelf. Can it detect it? There you go. So as you can see, every third frame is analyzing it and it's getting a confidence rating whether there's no elf in there or if there's an elf in that frame, and if it is, it's playing the sound. If it's above 95% confidence that there's an elf in there, I said to play that sound. Okay, so next in my daughter's very untidy room, the elf's hanging out with some other teddies. There you go. Her bed is just full of teddies. I have no idea how she manages to sleep in there. Okay, then next we have got the elf that's trying to hide a bit. Not very well. Okay, so managed to detect it then. Then the last one, we have got an elf somewhere unusual. There you go. Elf in the microwave. If you ever want to detect an elf on the shelf in your microwave, you've come to the right place. So there you go. So that is, you've seen it working, okay? It's not just smoke and mirrors, bells and whistles, smoke and mirrors. So just to round up the talk, I guess. So the main takeaways I want you to go away with are these models are very easy to train. Looking at this year's and last year's with its Christmas tree, you can export them to different formats for different platforms. I've not tried them on different platforms. What I might try and do is run it on a Raspberry Pi, run it in we're using Python, and then use it to sort of trigger an IoT device to like let go of a trap to trap the elf if it detects it using the PyCam or something like that. And again, you can use this to analyze real-time video. So whilst I have made this kind of fun and light-hearted and a bit silly, they are very, very real-world applications of being able to analyze real-time cameras for image classification purposes. So yeah, this is just a way of making it sort of a bit of engaging, and I think people learn a bit better when they're having fun. So yeah, that's the end of my talk. Hope you enjoyed that. Please do follow me on GitHub, LinkedIn, Twitter and YouTube, and do enjoy the rest of the festive holidays and the rest of the videos. Take care now. Bye.